Hello, chemistry students. We're now ready to move on to our next topic in chemistry. We're now going to turn our attentions to an important concept of solutions. And so, as we talked about last semester, solutions are a specific type of mixture that are evenly distributed throughout. And so, we're going to go ahead and, however, start with types of mixtures. And so, mixtures are pretty much everywhere around us. If you think about, for example, yourself, you contain a mixture of amino acids and proteins and sugars and things like that. The air, for example, consists of a mixture of nitrogen and hydrogen and oxygen and carbon dioxide and things like that. So mixtures are really prevalent around us, and so it's a good idea to talk a little bit about them. What we're going to be looking at today, we're going to see what are the properties of suspensions, colloids, and solutions and how they compare. So we'll define what each of those are. We'll also be looking at the types of colloids and the types of solutions. And then we'll also see how electrostatic forces in colloids are described. So remember, electrostatic, we have positive charges, we have negative charges, and as you guys remember, opposites attract. And so we will be talking about that. And so we do have some vocab that will be then defining each of those terms. And so let us go ahead and learn a little bit more about mixtures. We're going to go ahead and define a mixture as a combination of two or more pure substances in which each pure substance retains its individual chemical properties. All right, and so typically what happens is substances tend to mix, so it's difficult sometimes to keep them pure. And so because, again, when you think about the world around you, you think about thermodynamics, and you know that things tend toward entropy or disorder, and so it's going to be a lot easier for things just to kind of mix together, and therefore to separate out the different substances, it does take some additional work. And so as we talked about last semester, we can have things such as distillation, we can have filtration, we can do chromatography, and so those are some techniques that we can use to separate out the different components of mixtures. But again, it's not just going to happen spontaneously, and so it does vary depending upon the mixture. Remember that in order to classify a mixture, think about Shrek, and you think about Donkey, and you think about layers. And so the layers are what's important when it comes to the types of mixtures. And so if you only have one layer, Donkey, then you're only going to be looking at homogeneous mixtures. And so homogeneous mixtures are more commonly known as solutions. And so again, that's what the focus is on this chapter. So homogeneous mixtures and solutions are synonymous. They mean the same thing. And then we also have, when you have two or more layers, and so they're not going to mix together smoothly, and so those are referred to as heterogeneous mixtures. And so typically we just refer to those as mixtures. So we have homogeneous mixtures, which are solutions, and then heterogeneous mixtures, we just typically refer to as mixtures. And so those are the two different types of mixtures that we have. All right. Let's talk a little bit more about heterogeneous mixtures. All right. A heterogeneous mixture, as this picture indicates here, is a mixture where the individual substance remains distinct. And so we have a couple examples of this. And so if you're getting up in the morning and you remember to get your vitamin C by drinking orange juice is a heterogeneous mixture because, again, if you let the orange juice sit in the refrigerator, over time the heavier pulp will fall to the bottom. The liquid part of the orange juice stays at the top. Again, we have to have at least two layers in order for us to have a heterogeneous mixture. We can have things such as granite, and so granite is made up of different types of rocks, and so those are another example of mixtures. Your blood is made up of 4 different parts, and so we have red blood cells, white blood cells, platelets, and then the liquid portion is plasma. And so you can, however, separate out the parts of blood by using a device known as a centrifuge. And so basically, if you think about your dryer in your laundry room, basically works on the same principle. And so you're trying to spin it around very fast in order to get the water off of the wet clothes. The centrifuge, in the case of blood, you spin it at a high enough rate, and therefore the heavier red and white blood cells will settle at the bottom, and then the plasma, the liquid part, tends to remain at the top. So that way you could separate out the blood, and therefore you would see that it is also heterogeneous mixture. Even some solids you can consider as a heterogeneous mixture. So I myself am a big fan of pizza. If you think about pizza, you have the dough, you have the sauce, you have the cheese, you have the different toppings. And so you could, if you wanted to, pick off toppings off of a pizza if you either don't want them or you enjoy them. And therefore, that's another way that you can tell that it's a heterogeneous mixture. And so we oftentimes refer to these as just simply mixtures. Another type of mixture is called a suspension. And so a suspension is a mixture that contains particles that settle out if left undisturbed. And so an example of this, if we took cornstarch and water, that's together at first. If we go away for some time, we come back later on, we'll see that the cornstarch has separated itself out from the water. We can also look at sand and water, muddy water, and so we can see this would be our before picture, and then if we have some time, we'll see that the heavier sand will fall toward the bottom, and so we have the liquid water at the top. And again, because it's two layers, we know that this is a type of mixture, because that is how we define a heterogeneous mixture, is based upon the fact that it has two or more distinguishable layers. Right. We can also talk a little bit about colloids. These are suspensions of particles that are typically larger than individual ions or molecules, but they're too small to be settled out by gravity. And so we have, for example, fog, which is when you have a liquid dispersed in the atmosphere, which is made up of gases. We have something like whipped cream. Whipped cream is going to be a solid, and so or a gas that is suspended in a liquid. And then we also have something like butter. Butter is a liquid that's suspended into a solid. And so again, the particles are of a size that they don't separate out, but they're larger than the individual ions or molecules that make them up. So again, you don't have to worry about memorizing this table. There should be a table like this in your book, but I do want to show you that there are many different types of colloids. We have, for example, we have smoke. Milk is considered a colloid. Something like marshmallows. And so these are all different types of colloids. All right. When we're looking at the atomic level, if we zoom in, and again, we're going to try to see what type of forces hold these types of mixtures together. And so when we're looking at colloid particles, we can describe the movement of the individual particles using something called Brownian motion. And so Brownian motion, obviously named after a scientist by the name of Brown. He basically was looking at dust particles, and he was looking to, in plants, and he was able to see that in water, they were constantly in movement. And so another interesting side note is that Brownian motion was also used to help Einstein explain the photoelectric effect, and therefore led him to his Nobel Prize. So this was also used by Einstein to help explain how molecules behave and also help to prove the existence of atoms. The collisions will prevent the colloid particles from settling out in the mixture. And so this is very chaotic. You can't tell, for example, for an individual particle where it's going to go or how fast it's going, but the overall effect, you can say with some certainty how it's going to behave. And so, again, this Brownian motion is here to explain how colloid particles are able to not settle out because they're in constant motion. I want to talk also a little bit about a way that you can separate out colloids from other types of suspensions. A British scientist by the name of John Tyndall was able to show if you were to shine a light through a particular sample, depending upon the size of the particles, if they're too small, the light's just going to go right through it. If, however, the particles are large enough, it will tend to scatter the light rays. And so this has been known now and became known as the Tyndall effect. And so colloidal suspensions can typically scatter rays of light because their particles tend to be larger than those of other types of suspensions. And so basically, if you want to do this at home, for example, you can take out milk and you make up a little solution of milk with water, take a flashlight, and if you shine the light through the glass of milk, you'll see that the light will in fact scatter. And so milk is an example of a colloid. And so it's solid suspended in a liquid. The suspension here, because the particles are too small, is not going to cause scattering of light, and therefore it's just going to go straight through. You can also see this in nature, and so in the forest, either in the morning or toward the end of the day, the light will get to scatter as you go through a forest, so that's the Tyndall effect. And so even during sunset, some of the colors that are produced are also attributed to this Tyndall effect. And so again, the Tyndall effect is used to distinguish a colloid from a suspension. So the colloid will scatter the light rays, whereas the suspension will not. All right. We're going to turn our attention now toward the main focus of this chapter, and so we're going to be looking now at homogeneous mixtures. And so a homogeneous mixture has a constant composition throughout, and so just as I said at the beginning of today, it's also commonly referred to as solutions. And so typically we don't call them homogeneous mixtures in the lab, we typically refer to them as solutions. And so even though we think about them as liquids, such as coffee, or if we have a copper 2 sulfate solution in water, I also want to point out that this is probably my favorite color in the world just because of the nice blue. We can also have solid-solid solutions, and so if you remember from last semester, we refer to these as alloys. And so any sort of solution of two or more metals together, and so we typically find this in our currency as well. All right. You don't need to memorize this, but I did want to point out the different types of solutions that are around us. All right. Remember that the atmosphere that's all around us, the air that we're breathing in, is a type of solution, because I can't obviously go and pick out, let's say, for instance, the nitrogen molecules from the oxygen molecules. I can't do that because everything has been evenly mixed throughout. And so remember that air is made up of about 80% nitrogen, about 19% oxygen, and then 1% other gases. We can also have a gas-liquid solution, and so carbonated beverages will contain carbon dioxide gas in solution. Just as a little footnote, Joseph Priestley, famous English physicist and chemist, was also the creator of carbonated beverages. He worked a lot with gases and in fact discovered about 9 gases by himself. We also have liquid gas solutions, and so moist air will contain water droplets in the air, so in the morning or late at night when you look around and you see the fog, that is a good example of a solution. We also have ones that most people think about, so liquid. Vinegar, which we use in making different foods, contains acetic acid in water. And so, again, unless you use some sort of a distillation or filtration or some other sort of a technique like that, you are not going to be able to allow the acetic acid just to settle out and then get it for water. So that's not going to happen for that. And so this is a very common type of solution, is the liquid-liquid solution. Solid-liquid solution, for those of you who enjoy Kool-Aid or something like a powdered drink, this is a good example of that. It's a sweetened powdered drink. It contains sugar. You mix it into the water, you stir it up, and then you have a nice cool glass of Kool-Aid. And then you also, as we talked about previously, an alloy is a combination of two or more metals, and this is another example of a solution. All right. And so that is our talk today on mixtures. And so go ahead and do the homework, and I will talk with you guys again soon. Have a great day.